Our next speaker is unusual in many respects, in that most people, when they retire, they go and take it easy. They go to the shack and they work some DX or something like that. This guy went back to university, and this summer he hopes to graduate with a PhD in 6 meters, would you believe? But he won't be talking about his published papers academically. He's going to try and bring it down to our level and tell us a little bit about 6 meters and how to work the DX on it. Chris Deacon.
Hello. Am I on? Can you hear me, Mother? Right. Oh God. Excuse me. 6 meter sequels are never this. Well, no, they are this strong sometimes. So, and now for something completely different. Having heard about the evils of FT8 and how to run a huge de-expedition, brilliant. By the way, I did work you on 5 megs. First ever, of course, TN on 5 megs, so that was great. So I'm going to talk about 6 meters and explain, I won't name who it was, but I said to someone earlier, oh, I'm doing the 6 meter talk. We said, oh yeah, the crazy people. This person said, and I thought, oh, okay. Yeah, it is a bit sort of like that, because we're different. We do this, we play on 6 meters because it's hard. Not because it's easy, but because it's hard. If you want to, I don't know, work lots of, well, if you're into contesting, good for you. If you're into running big expeditions, definitely good for you, but don't go to Bouvet. We all have our own sort of interests in life, don't we? And I mean, if what you want to do is talk about your elements on a net, then go on 80 meters, do that, you know. But don't bother coming on 6 meters. The reason we do 6 meters is because it's hard. A bit like top band in that respect. So, let's see. Oh no, sorry, I meant to do something else. Let's see if I can make this go, yeah. All right, hands up if you've got a radio that covers 6 meters. That is 100%, I think. Oh no, not quite, sorry. Okay, now put your hands up again, please. Now keep your hand up if you've ever been on 6 meters. Well, that's quite a lot. Keep your hand up if you are on 6 meters regularly. Yeah, good. And keep your hand up if you think you're really serious about 6 meters. Okay, so you're the guys I've got to worry about. That's where the but you're wrong points will come from. Anyway, what people say is things like that. And the funny thing is, I mean, I've had to revisit this presentation, well, partly because Rob asked me to do an updated version of the presentation I've done before. But I've had to revisit it because now we're on the verge of, well, we're already beginning something different. There's some F2, there's some proper propagation, if you like, around. But I've had to sort of persuade people that actually there's still loads of DX guys, despite the fact that it's not Sunspot Maximum. But these are the sort of things people say. There's no DX. Well, there is. I worked KH6 last summer on sporadic E. I think mainly sporadic E anyway. Whenever I check the band, there's nothing there. You're not doing it enough. My answer to that. Or there's no activity. That's because you're not on. But none of it's true, but you do have to look for it, you have to search for it. And one of the reasons I have shall we say, a different attitude to FT8 than Chris down there, is that actually sitting with a robot or something, just CQing all day, which some people do, is not going to work you the DX. You have to work at it much harder than that. You actually have to look at what's going on. You have to understand where there might be some propagation and point your aerial the right way and all this kind of stuff. You just simply can't sit there and wait for it to happen. Now, I'm hoping that there's a little bit of music on this next one that may or may not. Can anybody hear that? It's quite quiet because I want to talk over it. I seem to have a bit of feedback. I'll come over here. So that's the original Mission Impossible. I'm sure, looking at you, yeah, most of you remember the original Mission Impossible. These folks here, and it's your challenge is to find Originally, I said Hong Kong there, but then that became too easy with FT8. So I've said VK3 now. It's finding it is the challenge. And the thrill of it comes from listening to white noise or watching a blank FT8 screen. Then all of a sudden, bang, it's there. And it's really exciting when it happens. So for me, my interest in radio has always been mainly about how the hell does my signal get from here to here? And managing to bounce a signal around the world, to me, is where the magic comes. And of course, that's the reason they call 6 meters the magic band, is because it seems like magic when it actually happens. I've only just come across this, just a week ago. This, so as you can see, I won't read it all out, was a submission from the ARRL for 6 meter access to the FCC towards the end of the war. And that's what he wrote. In other words, he's saying, it's no good for anything else, but we like it. That's the sort of thing he was saying. And the point is that 6 meters is, it's not VHF really, it's not HF really, it's sort of in between. It's either both or it's neither. It's no good for short-range communication because every so often you get sporadic E and do not adjust your set. If you remember those days of Band 1 TV and the lines across the screen and all that sort of stuff. But obviously it's no good for long-distance communication either because it's simply not reliable. But that's why we like it. Am I breathing on this too much? Maybe I'll put that down there. So sporadic E, which as I will explain shortly, is there throughout the sunspot cycle. It doesn't suddenly appear. And it's the bread and butter. And so you're sitting there just listening to white noise. By the way, I have a few recordings in here. Clearly, I've not got any recordings of FT8 signals. So they're all SSB and CW signals as examples. Can we hear that? I should say we're a little bit challenged technically today because there was a miscommunication and we didn't realise that, or the team didn't realise that there was going to be audio on the presentation. So we've got a microphone sitting on top of the laptop here. So hopefully you can hear that? Yeah? Yeah, all right. So that was just a single hop sporadic key. Single hop sporadic key works out to about 2,500 kilometers, something like that, which is less than F2, but because sporadic key is lower in the atmosphere. So we also get multi-hop sporadic key, particularly obviously over the ocean. It's particularly easy to imagine it bouncing off the sea. I've been on 6 meters since the mid-80s, and there's lots of people who've worked more countries than I have, but I've been having fun. We didn't realise, this was in 1985, it was sunspot minimum. We didn't realise we'd ever work any long-haul DX. And what's more, we were only allowed to operate before 8 o'clock, outside TV hours, in fact, before 8 o'clock in the morning and after about 11:30 at night. But we worked multi-hop sporadic key to VE1, W1. And so we sort of, for ourselves, discovered multi-hop sporadic key. Then we found out that the Americans had been using it coast to coast for years on 6 meters. So that's multi-hop. Some of you will remember GM3JIJ. John, who was a big 6 meter guy, unfortunately no longer with us. And that's, if you like, short skips. So the shortest skip that I've ever worked on 6 meters is around 400 kilometers. I used to live in County Durham. I now live near south of London, so I'm way down there. But Darlington, where I lived, is actually closer to Edinburgh than it is to London. And I could work the south coast sometimes, the English south coast. So 3 different varieties of sporadic key there. ON4KST, obviously, of course, and we all know now because of the ON4KST chat, or at least those of us who are into the more exotic bands use his website. So he was beaming west. Whoever recorded that, I think it was D3WOS, was also beaming west, and you get some pretty strong signals coming back, and it's one hop of sporadic E and then some scatter off a rough sea surface and back, and so you get a slightly sort of echoey response. You're all experts at CW, obviously. Okay, so that's aurorally, which has a different mechanism, is created by a different mechanism for normal sporadic E, and it tends to be associated with auroral events. So that was JW7SIX, a beacon on Svalbard. But there are lots of other ways. Ooh, yes, if I get too close to that, I need to stand back here. There are loads of other ways, and some of those I'm going to talk about some more TEP, transequatorial propagation, F2. And I make no excuses, by the way, for including a lot of propagation stuff in this. A is my interest, obviously. And I'm actually secretary of the RSGB's Propagation Studies Committee as well. But actually, to be an effective 6-meter operator, you need to have at least a basic understanding. You don't have to be an expert, but there's sort of a basic understanding of how the propagation actually works. If I can, without causing a huge hoop. All right, a little bit of, yeah. I'm not sure whether that's going to. I'll try it. Yeah, left and right. Yeah. Okay, so there's a little bit of science for you. So this chart is a NASA chart. No, sorry, NOAA. Oh, no, sorry, I'm talking about rubbish. It's Australian. But anyway, it's a chart that I've stolen. Here's the daytime ionosphere. Here's the nighttime ionosphere. That black line is the concentration of electrons, and it's the electrons that actually reflect or bend our signals. You shouldn't really think about the F2 layer or the E layer, because they're much broader than that, as you can see from the sort of shape of these things. And it looks like, I always think that looks like a face, and this looks like a nose with the guy sticking his tongue out. Sporadic. So what's going on here? Sorry, I'm in the way because I want you to read that bit as well. Is you've got a balance between ionization by the sun. So it's mainly extreme ultraviolet, very short wave rays from the sun up from the above. So that increases the ionization level. It kicks electrons out of oxygen and nitrogen, mainly atoms and molecules. And so it creates this area of free electrons, which when the radio wave encounters them, they move. And generally speaking, bend the radio wave, when we're lucky, back to the ground. There's a balance between that effect, which increases as you go up, and the density of the air. The denser the air is, the more collisions there are between the ions, the electrons, and the ordinary, the neutral gas, and that tends to make it recombine, so the ionization goes away. So the bottom region is actually the D region, which doesn't affect HF waves at all, except that it causes absorption. And when you get a radio fade out, particularly on the lower, below about 10 megahertz, it's because the D region has suddenly got thicker. And those electrons are moving, but they're banging into atoms, molecules of gas, and losing energy, and that causes the wave to lose energy. So the E region, so that's the D region. The E region never becomes thick enough to bend 50 megahertz waves. The F layer, whether it's, we tend to talk glibly about F2, but there are actually two separate sort of peaks in the daytime and only one at night. You can see that the ionization density is higher. There's more electrons, there's more free electrons. That's electrons per cubic centimeter, believe it or not that it really matters. And it's highest at that level, at F2. So that's about 300 kilometers above the ground. And just for reference, the International Space Station is about there. It's just under, it sort of goes up and down a bit, it's just under 400 kilometers above the ground. So that's F2. Of course, we are now approaching solar maximum, so all of a sudden the F2 layer's having an effect, and we'll talk about that in a minute. But sporadic E is produced by a different mechanism entirely. And when I heard that I was going to be introduced with an excerpt from one of my papers, I thought, oh my God, what's he going to do? But funnily enough, it was there's this bit about the creation of sporadic E. And Lorentz was a famous physicist. You might have learned about the right-hand and left-hand rules in your school physics or university or whatever you did. And that's how sporadic E works, because the electrons in sporadic E layer have come from metal ions, mainly magnesium and iron, which has mostly been created by meteors burning up in the atmosphere. There is a sort of link between sporadic E and the incidence of meteor scatter, actually, but not actually as strong as you think. They become ionized. Those gas molecules, when oxygen's ionized, it very quickly turns back into oxygen, if you like. So O plus ionized, singly ionized oxygen very quickly through various, they call it ion chemistry, very complicated, turns back into oxygen because it captures an electron. Metal ions take much longer to recombine, so they persist for a long time. Long enough for wind shear effects to actually create layers of metals and to concentrate those layers so that you end up with a sporadic E layer, which is very thin, might be only a couple of kilometers thick, whereas you can see, I mean, the E region is, 70 kilometers or something. And very, very dense, and therefore very capable of reflecting at much higher frequencies, including up to, occasionally, of course, 2 meters, and I think very, very, very rarely higher than that. So it's different mechanism, more or less independent of the solar cycle, and it's there all the time. And the point is that we can exploit it even at sunspot maximum because it helps us to get to the point where the F2 type propagation might be. So I hope that sort of makes sense. Very happy to take questions on that maybe later. I don't want to outstay my welcome. Now there's loads of DX to work on sporadic E. This happens to be last a couple of years old, but it's fairly typical. That's the DX cluster. It's not PSK Reporter. It's the DX cluster spots from 24 hours in June, which is the peak of the sporadic E season in the Northern Hemisphere in 2021, so 18 months ago. Loads of stuff, but you can see it's all pretty much, almost all of it is north of the equator. And the peak of sporadic E incidence, which is driven by solar tides and stuff. And I didn't actually explain the Lorentz forces. Let me just explain that. The reason that it concentrates the ionization, the ions, is the right-hand rule. Motion, field, current. So the wind's blowing that way. The magnetic field in the Northern Hemisphere is generally pointing downwards, causes a current of electrons that way, down, broadly speaking, down. So, and obviously, it also works the other way. So if the wind at that level is blowing that way, the wind at this level is blowing the other way, you'll get a combined effect which compresses that layer of ions, and they drag the electrons with them. That's what that sentence about Lorentz forces actually means. Okay, so there's loads of dx on sporadic key, always, every summer. And here's a bit of digimode. Oh, okay. Just to show you what is possible, there's this thing, it got given a special name, short past summer solstice propagation. I mean, back in the last time we had a decent solar cycle, the only way it worked in Japan on 6 meters from the UK, pretty much, was by side scatter from the Indian Ocean. But we discovered in about 2006, pre-digital, that there is actually a direct path in the summer because it goes very close to the pole. It's a long way north, which is away from where the major concentrations of sporadic key tend to be. But that's probably too blurred to read, to be honest. But every single one of those, and all but one of these traces, is from a JA. So you can find yourself the target of a pileup, which for those of us who the expeditions is a fairly novel experience. That one is a local G who was transmitting in the wrong period, but never mind. So that's a page 4. There's 40, oh whatever the number, 45 or something like that on that page. The special term was invented on the basis that it can't possibly be sporadic key all the way. But that night, you notice, by the way, this is Zulu time, so this is 12:30 in the morning on the 13th of July, I think, from what I remember from memory, whatever it says there. Oh yeah, 13th of July. And it was associated with aurora, and I think it was aurorally that allowed us to communicate on that path for about an hour. Very rare, very exciting for those of us who look for that kind of thing. You imagine, it might be the only time ever I experienced that. That makes it exciting to me. Okay, so let's talk a little bit about F2. So this is the classic radio wave bending by the ionosphere, sort of. I think we all probably know that radio waves don't just go ding-donk, generally. It's a bending process over quite a long distance. And this is a simulation that I did, a very quick and dirty thing, it's actually, interestingly, in the model that I was using, it's a thing called FARLAP, which is very good, the highest sunspot number I could put in, and it uses a smooth sunspot number, so this is like the average, was 200. So if I put a sunspot number of 200 in, the maximum frequency that it would actually bend back to the ground was actually 46 megahertz. So this is something for me to look at in the future. How come? I think it sort of emphasizes two things. Firstly, this is showing that even according to the basic theory, it should be possible at the maximum for 6 meter waves to be reflected back to the ground. Secondly, the skip distance tends to be long, sort of 4,000 kilometers, yeah, maybe 3.5, but it's in that kind of range, and that's one of the ways you can tell whether it's sporadic key or F2, by the way. Also, there's a sort of quite intriguing, some of the waves just miss the ground and then carry on up like that, as if you might get caudal hop or whatever. I think the other thing is, given, as I say, this is, I managed to make it bend up to about 45, 46 megahertz. I think that shows that most of the 6 meters EX by F2 is at the sort of extreme end of the range of propagation that you encounter during any particular period. That it's when the ionosphere is particularly strong, which could be caused by big solar flare. It could be caused by waves traveling through the ionosphere, and there's a thing called traveling ionic disturbances. You sort of go bang at this end. A volcano in Tonga that exploded not only sent a sound wave round the world, you've probably all read about that, that went right up into the ionosphere and caused ripples. But it doesn't take a volcano to do it. There are actually disturbances flowing around all the time. So it's extreme, but it happens, and I think it's been happening quite well. I know it's been happening a lot recently. I think it's happened to me very recently as well. So yeah, now that's not recorded last week, unfortunately. Funnily enough, we have worked VK8 on FT8 last year, year before. Not that guy, somebody different. Signals on F2 can be very strong. And I've had three, over the last few months, which I think were actually pure F2. They were all to the south, because it's sunnier down there, you know. The sun's higher in the sky, so the ionization tends to be stronger from the sun. Therefore, the F2 ionization tends to be a bit southerly. So it will open up first to the south. You can sort of guarantee that. But the TTA, SN, TZ4, God, what's this called? Yeah, that's the fella. TZ4AM and D4K all worked on SSB by me, and the signals were so strong and so consistent over quite a long period. They weren't doing the sort of sporadic key tends to do this. Goes up and down all the time. F2 sort of tends to come up, and then it goes down again. So I strongly suspect they were sporadic key. Let me see, F2 rather. There's also this thing we call transequatorial propagation, and that tends to come in sooner during a solar cycle. And it's between stations on, has this got a pointer? Yes, it has. I don't know if you can actually, if that's any use, but the ionosphere, for some sort of ionospheric chemistry and electric fields at the magnetic equator sort of reason, tends to be denser on about 15 degrees either side of the magnetic equator. And because there's a gradient, there's a horizontal gradient in the density, the ionization density, that means that it effectively is slightly tilted as well. So you can get this caudal hot mode, which between stations roughly on either side of the geomagnetic equator can be a very, very consistent source of signals. And because there isn't a bounce in between, it's lower loss than it would be. So if this is the Mediterranean and this is ZS, let's say, or V51 or something. Also, because it's approaching this at a more shallower angle, you get better reflection. An experiment for you to try at home is, if you look at a piece of paper like that, if you then look at it at an angle, you will often find that it starts to look shiny. The shallower the angle, the light, in this case, obviously, hits the layer, the better the reflectivity. And that also works with radio waves. So the only other point about this, about TEP, is that if it doesn't cross the magnetic equator, it's not TEP. That's a bit pedantic, but it's about transequatorial. But what you can also get, obviously, is that's F2, so you can just get a signal from here to here, if you're lucky. Sorry, I'm sort of in. Yeah, right. Oh, hang on, let me see if I can do this. Bit of sound. You can hear the pile up. That was V51YJ, so in Namibia. One thing that doesn't happen on FT8, or is much less likely to happen on FT8, not that I'm here to defend FT8, is pile-ups like that, where you've got people constantly calling over the top of the DX. One little advantage of FT8. There's a bit more discipline because, of course, if they're transmitting in the wrong period, they're not going to be heard anyway. No, sorry, let me do it this way. Right, so Aurora, just while we're at it, and that's yet another interesting mechanism. There was an opening just recently, last week, and obviously you guys in Scotland will be getting that rather more than I am in IO 91. I used to get it quite a lot when I was in IO 94 in Darlington, but I do still get it down there. And this is a recording I made. So his signal was not defective, his transmitter was not faulty, it was being reflected from the auroral curtain. And what happens with an aurora is that electrons from the sun, there's a thing called a coronal mass ejection, which is a massive explosion on the sun when a solar flare goes off perhaps, or a thing called a coronal hole, which is a gap in the where the magnetic field of the sun is just pouring outwards, sends this mass of charged particles, and the magnetic field, because the magnetic field constrains the particles and the particles create the magnetic field. There's a very intimate relationship between those two things, which actually flips the Earth's magnetic field and lets electrons or various charged particles, but let's say electrons, pour in near the poles. But because they're charged, they can't cross the magnetic field lines. They are forced to go round. So what that means is if you're reflecting off this auroral pillar of aurora, let's imagine, there's a whole range of different relative speeds. Some of the electrons are coming towards you, some of them are going away, and so even on 6 meters, which is a relatively low frequency, try doing it on 70 sems. Well, obviously it gets broader. You can have a signal that's a couple of hundred hertz wide. And by the way, FT8 won't work in that situation. In fact, once I asked Joe Taylor, well, which digital mode would you recommend for Aurora? And he said, I wouldn't, I'd just use CW. So that's one of the reasons I use CW. So that was PA4 VHF calling CQ there. So Aurora, bit of fun. But Chris, didn't you actually work Aurora plus long haul F2 or something once? Yeah. Yeah. Yeah, I remember it was quite notable though, because we were the only time they ever worked on auroral signal, I'm quite sure. Have you? Oh, send it me, I'll use that. Oh, well, I'm not talking to you. Ah, yes! The one who thought it was a DL. Oh, that's you. Sorry. No. Yeah, we put that in our magazine, of course. We were extremely chuffed about that. Also thinking, lucky bastard. Anyway, one of these days, hopefully, maybe with the magic of FT8, I'll actually work ZL. But a guy in DL, what's it now? Early January this year, was called by ZL3 out of the blue, just like that. I don't know if it was long path or short path, and worked in, and then it was gone. Don't let anybody tell you that FT8 isn't exciting. It might not be. It won't be when you're running a robot. Don't like robots. Anyway, so meteor scatter. Now, this one is the recording. Oh, God, I keep forgetting. This is not an amateur signal. That's the bit I was waiting for. So this is actually from the days of, it's quite old, this recording. From the days of VHF television in Europe, and that's an E2 48.25 signal. And that sound was the head of the meteor entering the Earth's atmosphere, burning up and slowing down, hence the frequency shift, the Doppler shift change. So that's meteor scatter, and of course that's what meteor scatter tends to look like these days. Some people are dead keen on meteor scatter. I'm not particularly, but there's a QSO that I had, and he sent me this. This is actually MSHV, and this is a time-based plot, and so there was a big burst of my signal there, which was enough to send 7.3 4 times. Okay, so let's talk about the sun for a bit, just a bit. On the left is a slightly doctored, not by me, view of the visible, an image of the sun in visible light, and you can see a few sunspots on there. They're not particularly big sunspots actually, but the big sunspots aren't necessarily better when it comes to producing good conditions for radio, because it's not the visible light, what you can see, that actually causes the ionization up there. It's actually the extreme ultraviolet, and this is from it's from the 11th, whenever that was, so 3 or 4 days ago. Captured by a satellite, obviously these days. This is an extreme ultraviolet image within about 20 minutes of the same time. And the sun looks completely different then, but you can see that that sunspot group there is associated with a bright area here, and these are the other bright areas they're the ones that are emitting this extreme ultraviolet that actually ionize the ionosphere for us, and that's really what we're concerned about. And when there's a solar flare, bang, you get a big flash of UV, which can cause what we used to call, back in the old days, I haven't heard it recently, a pre-auroral enhancement. In other words, you get this big flash of X-rays and extreme ultraviolet. It increases the ionosphere. 10 meters, 6 meters go mad. And then after a period of hours or a day, those charged particles I was telling you about from a coronal mass ejection that got kicked out from the sun arrive and kill the whole thing. But there's a period of enhanced propagation associated with brightness in the sun at extreme ultraviolet. So we talked about solar cycle. We've already seen one of these charts, so I won't drone on about it. We know, back. That cycle 24 was rubbish. Cycle 23 was okay. Cycle 22, which was the first one that I was on 6, in fact most people, the first one that a lot of our people, because I had one of the early 100 permits, but in 1987, 8, the band was released more generally. That was a good cycle. This was an okay cycle, and this was rubbish up here. And that red line is, as Chris already mentioned, that's the forecast, which was produced by a panel of learned experts back in 2019. And the grey is the error bars. It's the uncertainty that they saw in that prediction. And I think actually this version of that forecast has actually been shifted, been brought forward by 6 months as well, because they had the whole thing was happening later, and what they were forecasting was another cycle pretty much the same as 24, and 24 never really got strong enough to be much use at 6 meters. The TEP was there, but the east-west F2, if you like, was not there. And you can see that it's well ahead. Doesn't mean necessarily it's going to be a super-duper cycle, but it might. There is, as some people will have heard this week, a forecast by a team led by a guy called Scott McIntosh, who is a Scotsman, by the way, but he's based at the National Center for Atmospheric Research, or whatever the title of it is, anyway, in Boulder, Colorado, which is actually forecasting that the peak could actually be as early as the back end of 23. Or sometime 24 we can't assume that it's not going to happen, that it's some years away. But I mean, with this kind of trajectory, the black is the monthly average, so sunspot number. The purple, which you may be able to see, is the smooth number, because the whole thing goes up and down like a yo-yo. It's as if you're trying to measure your weight standing on the bathroom scales every morning. You know, one day you'll be whatever number of kilos, and the next day you'll be 300 grams heavier, and you wonder why. Well, it's just because it goes up and down a lot. You'd have to look at what the average is, and that's why this 12-month average is followed. What's slightly more useful from our point of view is, so that was sunspot number. This is solar flux. And it's ironic, really, that the two main methods for monitoring the solar cycle, sunspot number, which has the merit of being very, very long record since cycle 1 back in the 18th century, and solar flux. So sunspot number is just the number of sunspots. Solar flux is the sun's radio emissions at 10.7 centimeters wavelength, so a bit less than 3 gigahertz. Neither of those tells you what's happening to X-rays, the ultraviolet light, but they're the things that we've got. Generally speaking, rule of thumb for F2 on 6 meters, you need the solar flux to be somewhere north of 150, maybe 175. So you can see we're sort of in the zone now, and hopefully, of course, it'll go even higher. I remember one day in 1989 or something, in the days before the internet, when they used to announce the WWV solar numbers on 28885, and we all used to listen to it to find out what they were. It was actually over 300. So on a good cycle, on a good day, could be over 300, and obviously we're nowhere near that. I mean, my bet, if you wanted a bet, is that it's definitely going to be better than cycle 24, thank God, which is why the HF bands are very good right now. But it's not going to be the sort of big peak cycle. I mean, Scott McIntosh's first, or his team, their first forecast, which was a couple of years ago now, actually had it being one of the strongest cycles in the last 100 years. That's probably not going to happen, but nonetheless, still going to be reasonable, we think. So the F2 globally, F2 and TEP are happening now. This is a similar plot to that other one. Remember the one I had with sporadic E, 24 hours of sporadic E, which was all north of the equator. This is absolutely not north of the equator. But it won't escape your notice that actually it sort of stops short halfway up France, which is why Paul's in the zone and the rest of us aren't, or haven't, rarely in the zone. Generally, at the moment, we need a bit of sporadic E to help us. By the way, these things here, these tracks, aren't real. They were actually long path QSOs going the other way, but the way this map works on KST is assumes it's the short path. So it wasn't really passing over southern Scotland, I'm afraid, that path there. But of course, if you're really lucky, you can get some polaries or rurales down the other way, and you work that out. Okay, so I think we've every prospect of it getting better, and there's going to be more of it even here. Right, so there's a quick summary of the various different modes, and I just want to pick up one or two things. So sporadic E, it's sporadic it's called sporadic for a reason, because it's sporadic. But it does peak in May to August every year, in the northern hemisphere that is, and it tends to peak mid-morning and early evening, which is, if you're retired, you get up late and you can still work the DX, and if you're at work, you come home and find out what you just missed. Damn. So F2, on the other hand, tends to peak October, November, February to March, near sunspot, within 2 years of sunspot max. Well, we're in that kind of range now. Now, I played you a backscatter recording earlier. With F2, it's more common, much more common. I talked a bit about, and this is one of the areas where you as a sex meter operator has to be more alert. I had a QSO back in middle of March, where I was beaming, well, basically I worked WW1L, who's in New England, who I've worked quite a few times on sporadic E, Tim. We were both beaming about 60 degrees south of the direct path between us. And the point is, and there was no direct path. Now, so all these things actually do happen on HF as well, but usually in combination with a whole bunch of other stuff. Whereas on 6 meters, the scatter might be the only way that you can work something or somebody. And what that means is that sometimes FT8 can't cope with that scattering. And there's two answers to that. Either you go on CW. Unfortunately, that means that you lose maybe 12 dB of signal to noise, or you adopt a different digital mode, one of the Q65 variants, but I'm not going to go into that particularly. So the scatter all ties in with what was the cause of the scatter was, but be alert, my advice, for F2 side scatter and scatter, back scatter as well. Because what's happening is that, as I say, the level of ionization as you go to the south, you're both beaming. The MUF's not high enough directly between you, but it is high enough for you both to get to here. And then what you need is, I don't know, the rough sea surface, or it can be a mountain range or something that just reflects the signal on. Aurora happens at any time, but particularly good near the equinoxes. Transequatorial, it has a slightly longer sort of footprint than the normal F2. It doesn't really operate at solar minimum, but it certainly it's been going for a few years now. And then meter scatter, well, you get showers and whatever. So don't forget the sporadic E plus F2. So the peak for you up here, and actually for us in the south of England as well, this year, or this next few months, is likely to be April and May, because the sporadic E is ramping up, and it can give you a hop into the Mediterranean area, possibly over the heads of all those Italians and Spanish guys who can work the F2 when they feel like it, because obviously the signal bounces off the sporadic E, it bounces off whatever, goes back up again, and there is no sporadic E over here, so it carries on up to the F layer. This one was in 1991. I was in Darlington in IO 94, so more than halfway from London to Edinburgh. The guys in the south of England did not copy it. And what's more, it was a contact to the very southern tip of Chile, and that was actually the first 6 meter contact between the UK or certainly between England and Chile in 1991, because the sporadic E bounced me over the guys to the south on SSB. And this one's much more recent. I mean, you can imagine I sort of walked back in. This is one of the other features of FT8 is you actually see what was on there, what was coming in a couple of minutes ago. And I walked in just after breakfast, walked into the shack, and there were 3 CQ calls from VK3 BD. I've never worked VK3 on 6 meters, but I was able to get in there quick. I couldn't have done that particular contact. I think it would have been very marginal on CW, and obviously I wouldn't even have known he was there probably. So, getting started, I won't rabbit on too long. How long, when do you want me to finish? Oh, great. I'll just carry on. Now you guys are all very educated DXers, so you know what you're talking about. I'm afraid, some of you won't like it, but FT8 is now the main mode. And the reason for that is a bit different from HF. It's not because we're more lazy. It's not even because we're using low power and rubbish antennas. I think any signal, when it's been bouncing around the ionosphere for a bit, no matter how much power you're running, can be pretty weak by the time it gets to the other end. So what it actually does is allows us to extend the range. It's actually pushing the boundaries of 6 meters outwards, which gives us a lot of fun. So that's the advantage of it. But there is still plenty of SSB and CW, particularly, as I say, in Aurora. As a 6 meter group, we're trying to encourage the legacy modes, and for that reason, our contests, annual summer contest, is only legacy modes. And our marathons, where we sort of let people count squares for 2 or 3 months, one in the winter, one in the summer, has separate sections for digital and legacy modes. You'd be surprised. And naturally, CW is better than SSB, but sometimes signals are strong enough for SSB, no question. FT8 is better than either if you like it. I wouldn't worry too much about FM, and we might be interested to play with digital TV when that becomes a little bit more widely accessible. DX TV might be quite fun. So that's getting started, and you can get on the air with not much power and a vertical and a dipole. During the sporadic E season, just get on, and now is the time to think about doing that, because it will ramp up very quickly from the middle of May onwards, and there will be a few days with sporadic E in April, this month. So it's definitely worth getting on, and at the very least you'll work around Europe, and there's about 60 countries in Europe, as you know. Average station 100 watts, barefoot rig, and something a bit bigger if you want. The polarization of your antenna, as a matter of interest, doesn't make a lot of difference, and this is the only reference you'll find in here to my research activities. This, and one I'll show you in a second, is a live replay, or replay as live, of the polarization received from a beacon in Hungary in 2018 in August. Now, I'm told by the beacon keeper that it was transmitting with vertical polarization. As you can see, it's elliptical, right hand elliptical, and it's almost horizontal. So the polarization of a 6 meter and a sporadic E signal, which will be the same on 10 meters actually, can be very different from what was actually transmitted. And this is another beacon on almost the same track, slightly closer, the one in Slovenia. And that's actually coming over with left-hand circular polarization. And as you can see, it's flipping around all over the flipping place. So whereas having a vertical antenna will probably pick up more noise for you, especially an omnidirectional antenna, will pick up more noise and make your life a little bit more difficult. Fundamentally, the signals coming in don't retain their original polarization, just like on HF. Only sporadic E just makes it a bit more dramatic. Now, this one was actually transmitting with a horizontal antenna, and as you can see, it's nearly vertical, and it flips and it rotates and whatever. Okay, so you can work loads of stuff with QRP. This was a friend of mine, Robin, M1DUD. He worked 71 DXCCs, no digital, well, you can see the power and the best DX, 25 watts to the Caribbean, 250 milliwatts to TR8CA in Gabon, and there's this QSL. So it's possible to work whatever station you can put up, although obviously all you guys can put big systems up if you wish. Right, how to be successful. This used to say listen, 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 but obviously that's what you won't get anywhere. Just turn it on for 5 minutes and then turn it off again. If that's what you want to do, don't bother. Even the stuff to Europe, you can't. It sort of comes and goes all the time. You can pretty damn sure that there'll be sporadic E most days in June and July, but not always. worth learning to understand a bit about propagation. Sporadic key varies a lot. It tends to be quite localized, and will be shorter skip than F2 would be. Find out what else is going on the band, the DX cluster, and 4KST, blah, blah, blah. Beacons are perhaps less important than they used to be, although they're very useful for propagation research, by the way, so I like them. Also, there are people in the UK who have permits for transmitting on 40 megahertz. They're not amateur permits, but they are transmitting on 40 megs, 8 meters, which is quite a useful sort of early warning for the MUF reaching 6. But it's always best to find the DX yourself, but you know this. I mean, that's the same on any mode, on any band. Find it yourself before the pile-up, and you stand much more chance of getting through. But, you know all this stuff. At least the first few, you certainly know. FT8 is far too easy to make a crap signal with. If you see a signal with sideband at 100 hertz either side, 200 hertz either side, you can be pretty damn sure that there's hum or something on their audio. Also, you see signals with, he's on 500 hertz, and you can see the third harmonic on 1500 hertz, and so, you'll have seen that if you're into FT8 at all. Match your cycles. We have a bit of a protocol, whereas when we're working long DX, not within Europe, otherwise we'd all be transmitting at the same time, which is silly. Where Europe tends to transmit first, particularly when we're working JAs or North America. That means that we're transmitting when they're listening, and they're transmitting when we're listening, which is an advantage. Within Europe, clearly that's a waste of space. Always look for a clear slot. And one serious disadvantage of FT8, from my point of view as a 6 meter guy, is that you can't hear it. It's a serious thing, because you can't hear that, what Chris was saying earlier, the auroral flutter. But second best, you can see it. You can see it on the waterfall. Actually look at the bloody thing and see what's happening to that signal. You'll be able to see when there's the flutter there. And did you know, you can tell from looking, when as long as it's not a compound call sign, when a station's calling CQ on FT8. There's a little bit of constant carrier, very short, right near the beginning, which is quite useful actually, because if you're calling somebody and his trace has still got that little straight line on it towards the beginning, have a look next time you're doing it. He's still calling C. So that's the good idea, good timing to move your transmit offset or something. Watch the waterfall, because you'll learn about what's going on. So there you go. So a list of the resources. dxmaps.com is really good. I mean, a lot of the data from the paper that you were reading, actually I collected via dxmaps.com, because it collects data from the DX cluster, from Reverse Beacon Network, from PSK Reporter. There's also Jim Bacon's PropQuest, which is his working towards being able to forecast the maximum likelihood of sporadic key, and clearly we also have useful information on the 6 meter group website. Must get a new, this is ancient. So there you are, it's the magic band. Doesn't cost much to get on. You can get very good results with low power, as my friend Robin did with M1DUD, and it is addictive. You talk to any of the 6 meter guys around here, Kerry, the back there. It is addictive. Go and look on the 6 meter group website, and don't forget to join if you're at all interested. And I think that's it. Questions?
Questions, anyone?
Why do some people call it also the tragic band?
That was a joke,
of course, back in the day. But it does basically, with success comes failure.
If it was easy, it wouldn't be fun. And some of the time you find it, I mean, like this month, the last few weeks, listening for DX on 6 meters, in England has been fairly tragic. But there will be. There's the sun is rising. We'll get better DX in the future. Oh, here we go. Difficult question coming up.
Good talk, Chris. Just as an addendum, 3 days after that DL worked the ZL short path,
Yeah.
DK1 Max worked ZL1 long path.
Well, he's right in the south of Germany, though, isn't he?
Pretty impressive,
Max?
isn't it?
Yeah, it is. Well, that'll come. Just keep looking. What? I doubt it. Yeah. No. Okay. We'll be realistic here. You need to have a reasonable beam to work ZL. I think I would promise that. Hello.
Going back to your presentation about the different polarization.
Yeah.
Obviously, you said that the horizontal antenna was flipping virtual polarization quite a bit.
Yeah.
Does that mean generally that the horizontal polarized antennas tend to be more unstable when it comes to its polarization than the verticals?
No, it applies whichever polarization it's transmitted with. And what it's saying is that if you imagine that it's the effective polarization is just rotating a lot, that means that it'll be rotating past vertical some of the time, and it'll be rotating past horizontal some of the rest of the time. So that some of the fading on sporadic E, this is specifically on a sporadic E, is caused by polarization rotation. You've heard of Faraday rotation, perhaps. It's sort of Faraday rotation, only a bit more complicated.
Thanks very much for an illuminating talk. I'm just interested in the antennas.
Yeah.
When you say greater than a 6 element, is that so you get ERP or directivity or capture area? I mean, what's the
Well, that's interesting.
What's the issue with the big station, if you like? What do you have to get right?
Yeah, fair enough. Depending where you are, it's probably received noise, to be perfectly honest. I mean, I use LFAs not because they've got more gain than some of the other designs, but because they have very good side lobe performance. And that's both local electrical noise, of which there's plenty at 6, and I'm on the edge of a village, so relatively semi-rural, but I've still got loads of noises around, but also galactic noise as well. So that, rather than the extra 0.5 of a dB on transmit, it's more that. Yeah.
Okay, thanks very much.
Yeah,
Chris,
pleasure.
thank you.